My dear students, I come up with another video from gaseous state. This video discusses PV isotherm of carbon dioxide, or it is also called the liquefaction of gas, or it's also called Andrews experiment. Andrews experiment. Because the scientist G. Andrews introduced this concept. We know that gas can be liquefied. Gas can be liquefied by increasing pressure or decreasing temperature. Gas can be liquefied by increasing pressure or decreasing temperature. But decreasing temperature is the most relevant idea, better one. You know why? The reason is that decreasing temperature is a better one, because above a particular temperature, for a given gas, above a particular temperature for a given gas, that gas cannot be liquefied. That gas cannot be liquefied. Whatever the temperature applied, whatever the pressure applied. Okay. Therefore, there is a limiting temperature for any gas above which that gas cannot be liquefied, or above which that gas will be always gas. That temperature is called critical temperature. TC. What is TC? TC is called, it is the temperature above which a gas can be liquefied. Whatever may be the pressure applied. For carbon dioxide, that value is, for carbon dioxide, TC value is 31.1 degree centigrade. 31.1 degree centigrade. Okay. Now, critical pressure. What is critical pressure? It is the pressure required to liquefy a gas at its critical temperature. Therefore, in this case, this is a pressure axis, this is a critical temperature. Therefore, this is the critical pressure, PC. Okay? It is the pressure required for any gas to liquefy that gas at its critical temperature. Now there is one more concept, critical volume. Critical volume. It is the volume of 1 mole of gas, 1 mole of gas at critical temperature and critical pressure. It is a volume occupied by 1 mole of gas at critical temperature and critical pressure. Critical pressure of carbon dioxide is 72.9 atm. Critical volume of carbon dioxide is 940 ml per mole. ml per mole. Okay. Pc is equal to 72.9 atm. Vc is equal to 940 per mole. What is Tc? 31.1 degree. Now we can explain this graph. PV isotherm of carbon dioxide. This is a PV isotherm of carbon dioxide. Fine. This is A, B, C, D is the isotherm. A, B, C, D is the isotherm at 13.1 degrees centigrade. E, F, G, H is the isotherm at 25.5 degrees centigrade. Now this particular is the isotherm at 31.1 degree centigrade. You imagine you start from A. At A, volume of gas is very high because it's a volume axis. So that pressure very low because volume directly proportional to pressure. Volume is very high, so that pressure very low. Now you simply start decrease the volume. When you decrease the volume, pressure increases. That is, when you decrease the volume, molecules come close each other. Therefore, a force of attraction work out, and at a particular point, at B, in certain gas molecules, force of attraction will be higher than their kinetic energy. Force of attraction will be higher than its kinetic energy. Because of that, gas condenses. That is, gas converted into liquids. Therefore, at B, liquefaction starts. Underline. At B, liquefaction begins. Not all gas liquefied. Certain gases become liquefied. Now, B liquefaction begins. From B, having noticed that volume considerably decreased, but pressure is not changed. You know why? Because from B, gas converted to liquids, and that continues till C. When all gases are converted to liquids, volume will be very small. But now they are converting to liquids, there is no impact of the pressure because all the pressure applied are converted into liquefaction. Therefore, there is no impact for pressure there. Therefore, along BC, you have both liquid state and gaseous state. Here, gaseous state is more, liquid state is less. When you come here, liquid state is more, gaseous state is very less. At C, all gases are converted to liquid. Therefore, at B, liquefaction starts. At C, all gases become liquid. Now you imagine, again suppose you are applying the pressure. Pressure axis increased, but volume is not changing. This is because you cannot compress the liquid. You take a liquid, then you try to apply the pressure. Does its volume change? No. That normally does not happen. Therefore, the single answer, along CD, you applied more pressure. Pressure has been applied, but volume is constant because at C, all gases are converted to liquid. Liquid is incompressible. Yes, now we can go to same isotherm at a higher temperature, 25.5 degree. You had the same shape of the graph, But have you noticed the length of this horizontal position reduced? Length of this position reduced. That is the area of both liquid and gas reduced. Or we can say once again, all gases are converted liquid with a short period of time. That is why this length reduced. Now if you draw a graph here, again length reduced. If you draw a graph here, again length reduced, again length reduced, again length reduced, again length reduced. You know, at this point, that happened at 31.1 degrees centigrade. At a particular point, gas at this temperature, all gases are converted to liquid in a point. Okay. Now, what is this graph? This graph, this is the gaseous state. This graph is the original PV isotherm. This is the PV axis. That is Boyle's law isotherm is this. Okay. This is a Boyle's law isotherm. These are not Boyle's law graph. This is a Boyle's law graph. Above this temperature, you cannot liquefy. Whatever the pressure is applied, at every pressure, that gas will be gas. Therefore, here, above this temperature, the gas will look like Boyle's law graph. But below this temperature, PV isotherms are not Boyle's law isotherms because there is a liquefaction. Okay. Now this is a critical temperature of the carbon dioxide. This is a critical pressure of the carbon dioxide. The volume at that critical temperature and critical pressure is a critical volume of the gas, carbon dioxide. Value I have said here. The physical state of gases, this area is gas, this area below this area is liquid, this area is liquid gas together. Yes. Now I discuss another topics, continuity of state. Continuity of state. Continuity of state. Continuity. What is this? The question is, can you convert gases into liquid state without passing an intermediate, that is gas liquid intermediate? Once again, can you convert a gas into liquid state without passing through an intermediate state, that is gas liquid state? Because normally gases are converted to liquid passing through an intermediate gas liquid intermediate state, except in critical temperature. In all other cases you have an area, this type of area. Under this area you have liquid gas state. This is a question. Okay, you can do that. Suppose, imagine a gas at this point X. At the point X, you have a volume. Gas molecules are here. You have a volume. Okay. This is a volume of gas at point X. Now imagine you give the heat to this gas at a constant volume. You give the heat to the gas at constant volume. What happens? At constant volume, temperature directly proportional to pressure. When heat gives, temperature increases, pressure also increases. Pressure increases. Therefore, this gas at constant volume, you are heating at constant volume, therefore pressure increases like this. Imagine it reached at here. This pressure is above the critical pressure. But still at gaseous state. Because you have given the temperature. You have given a temperature above the critical temperature. Okay? Now you have reached at this point. Okay? Yes. Now you start cooling. Now start cooling. Decrease the heat. Start cooling at constant pressure. You maintain that pressure. At constant pressure, you start cooling. That is temperature directly proportional to volume. If temperature decrease, volume will also decrease. That is at this pressure, you start cooling. Therefore, you know what happens? That has been done at constant pressure, you know. Therefore, volume started to decrease. Volume started to decrease. Volume started to decrease. This route. Pressure same. Volume decreases. You know, volume enter this area. That is Z. At this area, what is the state? Liquid state. At this point, along this point, temperature decreased. At this point, particularly, I will tell you, when it enter to this area, says Z point, all gas will be converted to liquids. Therefore, in this state, without intermediate, the gas are at a point converted to liquid. This is called the continuity of gas. That is the transformation. Continuity of state says that transformation of gas directly into liquid without going through intermediate of gaseous liquid state. This is possible as I mentioned through the graph. Okay, I hope this video is clear. If you find any difficulty, let us discuss. Thank you.